Okay, so in this video I want to talk mostly about the clone object and using that to create polyphony both from a synthesizer and a sequencer. Now I'm using a synthesizer that I built recently and kind of explained the operating function of in my previous video, and you'll see inside it in a second. So in general this is like an additive synthesizer, which means that I'm stacking up a bunch of oscillators. Instead of directly generating like a square wave or a sawtooth wave or something, I'm creating those wave shapes as the sum of sinusoids. Um, so I talk about that in the other video, but that's why you see so many oscillators stacked together when I open up the object here. But so you can see right here, you can see the syntax, clone. This is the name of the subpatch that I'm cloning, additive synth v4, and then the number at the end is the number of instances that I want to use. So the clone object is pretty simple. Um, Fundamentally, though it can be a little tricky to implement, and so I'm going to talk about some of the hangups that I overcame. And number one, you can see that most of the parameters that I want to modulate, I have abstracted them to this top level here. So you can see this is my ADSR envelope attack time, sustain level decay time. I guess it's an ASDR envelope. And over here are some of the parameters of the of the wave shaping. These are some of the wave shaping capabilities I have over here. But the point is that you'll see that I am not using these as inputs to the additive synth block. I'm sending them inside this subpatch with the send and receive capabilities from within PureData, and there's a good reason for that. So PureData gives you a pretty nice block to use called Poly. I abstracted it to allow you to switch between multiple levels of polyphony. So you can do one note polyphony, 4-note, or 8 according to here. Of course, 8's not going to work because I've only allowed 4 instances of the synth. But you know, this is all just kind of a very fluid work in progress. But anyway, so that's all this poly does. Inside poly switch is just 3 instances of this block called poly. And essentially all poly does is takes your notes in from your synthesizer, or sorry, from your keyboard, and you'll usually get 2 pieces of information, the key number and the velocity. Poly takes those 2 things and puts an instance number in front of it, and that's essentially all you need to go into this clone block. So it'll tell the clone block that on instance 0, and it's 0 indexed, so I have 4 instances, which means they're essentially so labeled 0, 1, 2, 3. At instance 0, I'm sending you note 55 with 127 velocity. At instance 1, I'm sending you note 57 with 120 velocity, whatever. But so that right there is the reason why you generally want to use these send blocks to modulate parameters within the synthesizer or within whatever you're cloning. Because otherwise you will also need to put that instance number in front of anything that you're trying to get inside this block. So if there's 4 instances and you're not sending it some vector where the first element of that vector is a 0, 1, 2, or 3, you're going to get this error that says, I don't know which instance of the 4 clones that I have to send this to. So unless you want to discretely control the attack and decay times, let's say for instance, of the individual voices, then this method is much easier because you'll be sending this attack time and it'll be received the same by all 4 instances of whatever thing that you have cloned, or all n number of instances of whatever thing you have cloned. So I'm sending this thing, I've called it I called it a Tim because I wanted to keep these all the same number of characters. Um, so it's a Tim, and there's an R a Tim somewhere, and because I've cloned additive synth 4 times, there's actually 4 instances of R a Tim, and that receive block R receives this same thing for each 4 instances. So that means the attack and decay times, etc., are consistent across all 4 voices, which I think for most uses is what you want. However, if you want to discretely control individual elements of your voices, then you can still use the clone block. You just have to, pack whatever data you're trying to send into a vector and put that instance number as the first element of that vector. Or you could just take whatever thing it is that you're trying to use multiple instances of and just use multiple instances of it. So instead of having clone additive synth 4, I could have an instance of additive synth, another instance of additive synth, another instance of additive synth, etc. Okay, so I'm going to click on the additive synth block now and go inside, and you'll see I'm obviously using PowerPoint here for the ease of the built-in Windows screen recording app doesn't let you switch windows, so that's why I'm using PowerPoint here. But on the top you would see this. I've stepped into additive synth now by control clicking it, and you'll see in parenthesis 0, which I believe is referring to, you're looking at the 0th instance of this, and there's also a 1 instance, a 2 instance, and a 3 instance. But on the inside they all have the same thing, though they might be receiving different information. And now in line with what I'm taking at the input, I also have this sequencer. And so the sequencer that I've written, I think, works really nicely because you can just put it in line here, and when you're not playing the sequencer, all the note information that's passing through the sequencer is just passing right through. So I basically had written this whole synthesizer block and then written the sequencer block separate, and then I just stuck it right in line here. And when it's not being used, all the note numbers and the velocity information is just getting passed right through. And that makes sense because the sequencer needs that information too. So there's no reason why I couldn't just let it pass through the sequencer. Anyway, so here you can see where I'm receiving some of that stuff from the abstraction above. You can see where I'm receiving all of it, essentially. So there was, sorry, I just touched the microphone by accident there. So you can see there was this is a switch if you want the attack level to be set by velocity. So I'm receiving that. It's either going to be a 1 or 0, which is setting up these spigots to either it'll use 1 all the time by default for your attack level, or to use the input from the keyboard. So what I'm getting from the keyboard is 2 things, the note number and the velocity. So the second piece of information here coming out of unpack is the velocity. So I'm just using a spigot to either accept that or not, and then divide it by 127 because the velocity is bound between 0 and 127, and I want it to be bound between 0 and 1. And yeah, there's my attack time. There's the sustain level, which also needs to be dependent on velocity if that option is selected, which is why that's also connected to this spigot and the velocity. And then my decay time and release time. That's what R stands for. And some of the other stuff that you saw. So again, there are 3 other instances of this, but every one is receiving the same information at these, RD time, R time, which makes it really, really the best way if you just want to kind of simply duplicate a synthesizer or some sort of abstracted oscillator to create multiple voices. And so now I'll go inside the sequencer and note that because the sequencer and anything that's inside this patch here now is itself has multiple instances. So I used clone additive synth 4 to create 4 instances of additive synth, which means there's 4 instances of everything in here, and therefore there's 4 instances of the sequencer. So the fact that the sequencer is in line with everything here means it itself is also polyphonic, which is probably something that you would want. So the logic here is a little messy, I guess, complicated. But so one of the things I'm doing off the bat is the note release information that you're going to get is, for anyone who doesn't know, you'll get the note number again, or the key number, and you'll just get a velocity of 0, and that's essentially your note off information. So I'm actually using that out here to set the release part of the the decay time shouldn't have, I dragged these over here to kind of separate them visually, but the decay time belongs over here with the other. The attack, decay, and sustain are all part of the first part of the envelope, and then the last thing you want to do is you want to trigger the release as soon as you release the key. And so that's what this select 0 is for. When you get, again, this is the second inlet here, the second element of the vector is the velocity. If the velocity is exactly 0, I'll bang this, it'll get packed with this release time. It'll send the release time to the V-line object, which is off screen here, and it'll multiply that. The V-line will get multiplied by the oscillator. So you're basically just using that velocity equals 0 as a flag to do some stuff. So that's why it's important for that to be passed directly through the sequencer. I don't really want to act on it for the sequencer. I don't care about note releases, I care about note presses. But in any case, so if it equals 0, it essentially just gets passed right through if the velocity equals 0. So that's what this one spigot is for. For anything that's greater than 0, what I essentially want to do is take both the note number and the velocity and store it. And I just am using these 16 number atoms, well 32 total, 16 here and 16 over here, number atoms to store the note numbers and the velocities corresponding. And you know, I just put this up here. If there's anybody who's interested in it, you don't really obviously have to listen to my commentary. You can see everything that's set up and maybe glean from it what you will. But the method by which I'm doing this is essentially just recording the last 16 key presses. So every time you press a key, this gets banged, and this might look familiar. This is a very common way to kind of set up something that increments and resets. So this number atom here is constantly circulating about 16. So it goes from 0 to 15. And that's how I set which one of these number atoms I want to store into, and also how I set which one of them I want to read out of. So each time you press a key, this gets incremented, and it packs that as kind of similar to the way we deal with the instances of clone. It sends this number and packs it with the key press and velocity data, or the key number and velocity data. So to this root, I'm passing actually 3 values. I'm passing something 0 to 15, which is how it ends up in one of these slots, and then also the note number and the velocity. The first thing root does is it strips off that leading value. And it's really useful in that way. It strips off the leading value, but routes it to the corresponding output. So For instance, if I'm on, slot 0 here, I'm adding that 0 to the beginning of the other two pieces of information I want. Root takes that, it says, okay, this belongs in slot 0. It gets rid of the 0, and then it just sends the note number here, and it sends the velocity number here. The complicated logic is essentially to prevent bangs from also sending out the information to the output again multiple times, because there's some amount of, like, obviously not recursion, or there's some like feedback potential here, because not audio feedback, but that the information can feedback with that's kind of just the idiosyncrasies of the way PureData uses bangs. Some of that information can essentially be sent out twice unless I use these spigots, but the reason it can be sent out multiple times is because I want to have this second pathway where you can, instead of reading that information in, you can use bangs to send that information out. So that's instead what this select is for. And turns out that I was experimenting here, and then I didn't want to reconnect things, so these are all just kind of set to 0. I'm adding 0, I'm doing mod 16 when I had already done mod 16, so this effectively does nothing. But I set this up so that on the top level, I'm sending the words play or the words stop. And the metronome block already accepts the word stop. And I used a root block to accept the word play. So that's another thing with root. You can set it to accept any arbitrary string, and when it sees it, it'll bang something. So basically what happens when so this is receive sequencer command, which is going into the root block here. When play happens, it's a little confusing because the word play happens to be right above this outlet here, but the word play actually corresponds to this outlet. So when it gets the command play, a few things happen. This spigot gets activated, and this spigot and this select are what's corresponded with banging things out. The metronome gets activated, and now it's the metronome that starts incrementing this counter here instead of the key presses. So the play is also connected to a 0, which closes the things that I need to close. So it prevents the key presses from incrementing the counter now. It prevents things from getting passed into this root. And if I didn't do that, every kind of bang from the metronome would overwrite data here. So that's why I need to have everything connected to spigots and use the words play and stop connected to the corresponding 1s and 0s that allow me to open and close the things that I need to open and close, given which of those two functions that I'm trying to do. So this is a little convoluted. It works. One thing I have left to do is I need to make an extra button essentially to add a 0 here when it's convenient. One of the problems with this logic is I'm fundamentally rejecting velocities of 0 because those are often note offs, which I do want to reject those, but if I want any sort of syncopation, then I need to be able to skip notes or basically add a rest, and I don't have that functionality right now. It just records the last 16 key presses, and that's that. So it's just a straight plays 16 notes with uniform spacing. There's no possibility for syncopation. So that's one thing I need to do. I kind of need to, after this logical operator here, need to add something that allows you to stick a 0 velocity in here somewhere, which will essentially behave as a rest. But aside from that, that's how everything works, and that's how you use the clone object to get the polyphony. And again, this just works in line with the input from that additive synthesizer block, which is cloned, and therefore this is also cloned.